Alright, this video is going to be about interval notation and how they relate to inequalities. And so the first thing that we're going to talk about is we're going to talk about unbounded intervals. So many of us know our inequalities already, are less than, are greater than, are less than or equal to, are greater than or equal to. That kind of stuff we already know, so I'm not going to go over that. But what I want to talk about is this idea of an unbounded interval. So let me give you an example of one. So the first one I'll use is x is greater than 1. And so x is greater than 1 would be representing all real numbers. If x is defined in the real numbers, x would be any real number greater than 1, but it wouldn't include 1. And the reason this is unbounded is because it's any real number greater than 1, and it just keeps going on forever. An easy way to do that, you may remember making graphs on number lines like this, where you put like a 1 and there's tick marks that come after it representing the numbers greater than 1, and you would use an open circle and then you draw like some graph like this saying it goes on forever to the right, therefore the graph or the set or interval is unbounded. And so the way to represent this in interval notation is to use parentheses and brackets. So parentheses, if you ever use a parentheses, this represents equal to. And if you use, brackets represent equal to, parentheses represent not equal to. So the way that our example works is we said x is greater than 1, but it's not equal to 1, so I would use a parentheses around 1, and since the graph goes on forever, it goes towards infinity. And so you can't equal infinity either. And so the way to write this as an interval, the interval representing this would be represented by 1, infinity. And we always go least to greatest. So you start with the lower number of the interval and you go to the higher number, and so 1 to infinity. So that's an unbounded interval because it goes to infinity. It doesn't ever end. Alright, so another example of an unbounded interval would be something like this. So let me use this one. We'll do a few things. 2 is greater than or equal to x, and so a lot of people don't like looking at it this way, but what it really says, if you think about the graph, 2 is greater than or equal to x, it means that 2 is the biggest number that you could equal, and so we'd have a closed circle, and that all the values that are going to be solutions for x would be less than 2, right? Another way of looking at this would be to say that x is less than or equal to 2 if we flip it around. And so how would you write that as an interval? The way to write it as an interval, right? So since we can equal to, we're going to use a bracket, but now the bracket's going to face this way around the 2 because 2 is the biggest number. Negative infinity in this case is where that arrow is pointing, and that's actually the lower number. So the interval would be negative infinity, 2 with a bracket. And so there's two examples of an unbounded interval. Another one we can have is obviously we can have bounded intervals. And so a bounded interval would be where you have actually an interval enclosed between two numbers. So I'll just do one example. So take 0 is less than x and x is less than or equal to 2. So all the numbers that are being described here are just in between 0 and 2. They would not be anything less than 0 or anything greater than 2, and so all your answers are there. So you'd have an open circle around 0, and you'd have a closed circle because it can equal it. So what does an open circle mean? If we're talking intervals, an open circle means parentheses. A closed circle would mean brackets. So this would be 0 because that's the lower, 2. And you don't have to draw graphs, but sometimes it's nice to see it visually before you write the interval. But really all we're looking for is this. And that would be a bounded interval because it is enclosed between two numbers. So let's just play a game. I know this is weird because it's like a YouTube video of me talking and doing math, but let's just play a game. So here we go. Let's say -3 is less than or equal to x less than 5, right? So I'll give you a second. You can hit pause on the video, and you can try and do that one on your own. Or I'll just take a quick 5-second pause and let you think about what it would be. Alrighty, so here we go. -3 is the lowest one, so that's going to be the one that we write first. 5 is the greatest, and so that'll be the one that comes second. Since -3 is less than or equal to x, we'll use a bracket, and 5 is less than x, so or x is less than 5, so we'll use a parentheses. Alright, and that would be our bounded interval. The last thing that I would say is you probably should know a little bit about, and you may already know a little bit about, the union between intervals. And so the union between intervals is pretty important, especially when we're looking at domain and range, or when we're looking at solutions to answers of inequalities, or even when we're looking at all different types of math situations. So here we go. Let me give you an example where you would need the union. So let's say that 0 is less than x, right? Or x is less than or equal to -2. So I know some flipping happening, and we have a word or going on. So what this is called a compound inequality. And we have two of them. You've already actually seen one. The first one was on the last page that I went over, unbounded intervals. And that one is an and inequality. So an and inequality encloses two numbers. An or inequality actually brings two different intervals together. So take a look at this. This would be 0 is less than x, which can also be written as x is greater than 0. So if we were going to write this as an interval, it would look like this. 0 to infinity, no brackets because it's not equal to, right? And then the other one is x is less than or equal to -2. And so negative infinity would be in this interval because it's going less than -2. And then -2 would have a bracket because it equals it. Now this looks kind of weird because it kind of goes out of order. So with interval notation, we always go least to greatest. Right, so least to greatest is the first thing that you want to do. And so least to greatest would mean negative infinity is the lowest on a number line. So negative infinity, comma, -2 with a bracket, and then 0 to infinity, parentheses. And now how do we join those two things together in a union? We have this symbol that represents the union, saying that these two sets are together even though none of their numbers intersect or are shared. They still can be joined together with the u that looks like that. Don't pull down the u and make like a lowercase u, just one u like that, and that would represent the union between two intervals. Those two intervals don't always have to be bounded, or excuse me, unbounded. Those two intervals can be bounded if your domain or your range required it. So if you had something like 0 is less than x less than 2, or x is greater than 4, this could also be using the union. So you have a bounded interval, which is also considered an and inequality. So 0, 2 joined together with x is greater than 4, 4 to infinity. Right, so these describe, in the same way that an inequality does, these also describe the numbers. Right, so this says all real numbers between 0 and 2, but not including 2 or 0. And this says all real numbers greater than 4, but not including 4, and that these two sets are now coming together to make one set. So that would be a way to represent two sets coming together in the union. All right. There's a lot of uses for these interval notation kind of situations: domain and range, answering inequalities, and a whole lot of other things. We use interval notation with increasing and decreasing portions of a function. It just goes on and on and on. So really make sure you understand how to write things in interval notation. All right, have a great day.